Hello kids, my name is Jerome. Today we are going to talk about fluid mechanics. Let's first discuss about fluids. A fluid is defined as any substance that can flow, so liquids and gases are both considered as fluids. The study of fluids will be treated from two different approaches. First, we will consider only fluids that are at rest. This is called fluid statics or hydrostatics. Second, we will study the behavior of fluids when they are in motion. This part of the study is called fluid dynamics or hydrodynamics. Let us start the study of fluids by dividing and analyzing the macroscopic variables. Let's begin with density. This is defined as the amount of mass in a unit volume of that substance. Use the symbol ρ to designate the density and write it as follows. The concept behind density is as simple as a piece of cake. Let's take myself as an example. If I eat and eat, I will have a large density. That means I have a great deal of mass in a unit volume. Whereas, if I go to gym every day and follow my diet, I will have a low density. Meaning to say, I will have a small amount of mass in a unit volume. That will happen in the near future. Density is expressed in SI units as kilogram per cubic meter, and occasionally in the laboratory as gram per cubic meter. Densities of solids and most liquids are very nearly constant, but the densities of gases vary greatly with temperature and pressure. Let's try to grasp the concept now with some examples. Jerome placed his phone on a balance scale and found out that it has a mass of 300 grams. Then, he placed his phone in a container of water. By doing that, 30 cubic meter overflowed into an attached calibrated beaker. Compute for the density of the material. Pause the video if you want to solve it. Really now? All you need to do is to remember the formula for density. Density is equal to mass over volume. Therefore, 300 grams all over 30 cubic meters is equal to 10 grams per cubic meter. Now, your professor might ask you to express your answer in SI units. You will simply use dimensional analysis for that. The answer should be 10,000 kilogram per meter cubed. This will be our last problem for today. Let's read. Jerome, being a future engineer himself, would like to create a swimming pool for his home. If the dimensions of the swimming pool are to be 3 meters long, 2 meters wide, and 1 meter deep, what mass of water is necessary to fill the pool? The density of water is 1000 kg per cubic meter. How should we solve this problem? Pause it if you want to solve it. Let's first manipulate the formula for density to find the mass. It should be density is equal to mass over volume. If we multiply volume to both sides, the resulting formula will be mass is equal to density times volume. The density is given in the problem. Hence, the mass of water required is mass is equal to density times volume. In order to get the volume, the formula for volume of a rectangle is length times width times height. So, in order to get the mass, density times volume is equal to 1000 kilogram per cubic meter times 3 meters by 2 meters by 1 meter, and the answer should be 6000 kilogram. As a matter of curiosity, let us compute the weight of this water. The weight of the water is given by weight is equal to mass times gravity. Therefore, 6000 kilogram times the acceleration due to gravity, which is 9.81 meters per second squared, and our final answer is 58,860 newtons. To give you a feel for this weight of water, it is equivalent to roughly 13,295 pounds. It is equivalent to 3.5 cars, since an average car weighs 2 tons. In some cases, it will be necessary to reinforce the floor underneath this waterbed, or the bed might end up in the basement below. Okay, that's it for this video. I hope you spread this video to help other people out there. We will discuss more about fluid mechanics. This is Jerome saying, World Peace.